More than half of the global population lives in urban areas, and this proportion tends to keep growing. Although the water use per capita has been decreasing, mostly due to better practices, water abstractions tend to grow in urban areas as population continues to increase. At this pace, adjusting infrastructure to meet supply can become a challenge. Furthermore, uncontrolled urban growth, especially in developing countries, increases rivers and lakes pollution, reducing freshwater availability for potable use. If you add climate change to this equation, as we expected more frequent droughts, and we are facing a challenge to supply water in urban areas for the near future. To face these challenges, we have to change our ways to consume water, looking beyond traditional resources, fresh water from superficial and groundwater resources, and we should encourage the use of non-conventional water resources. According to FAO, the Food and Agriculture Organization from the United Nations, non-conventional water resources refer primarily to wastewater, desalinated and fossil water. In our context, we consider as non-conventional water resources that are not normally used to supply water. These non-conventional resources can supply water for several non-potable uses, such as agriculture and landscape irrigation, street cleaning, toilet flushing, and industrial uses. Sustainable Development Goal number 6, clean water and sanitation, includes pursuing water using efficiency that meets with adopting non-conventional water resources. Did you know that about 50% of water used in a domestic household can be supplied with non-potable water? We can save a lot by adopting non-conventional water resources. And what are those resources? Some examples largely available in urban areas are rainwater collected from roofs, superficial groundwater drained from buildings, both types that otherwise would be discharged on the sewer system, increasing flood risk. You can also use residual water from sinks, showers, baths, washing machines or dishwashers, referred usually as grey water. Another example of non-conventional water resource is reclaimed water, as wastewater after undergoing through a wastewater treatment plant. In this case, we have some extra benefits, since reclaimed water can provide nutrients and organic matter for soils that are essential to agriculture. The main processes to supply water from non-conventional resources are basically the same as traditional ones: collection, treatment, storage, and distribution. Depending on the resource type, some specific aspects should be considered, where the main factors are spatial and temporal availability. For instance, rainwater is spatially distributed and can be collected and used on the same building, requiring, however, a specific network for distribution. Nevertheless, the availability is not constant over time, depending on the rainfall frequency and therefore requiring a storage tank to supply during dry periods. The storage tank has the function to storage excess water during periods in which the rainfall volume inflow is greater than the required water volume outflow. When the opposite occurs, the tank delivers the request with the water volume that was previously stored. In the case of grey water, due to a relatively constant inflow, only a minimum storage for operational reasons is necessary, and for short periods avoiding contamination. In this case, the amount is also spread over the area and can be used on the same building where it is generated. Reclaimed water, although constant in time, is available on the wastewater treatment plants, requiring transportation to the end user, not necessarily on the same location. To avoid health risks, non-potable water must be well signed and if using a dual network, attention should be held to avoid cross-connections. An important barrier towards water circular economy lies on costs, especially where the water tariffs are relatively low. A careful cost-benefit analysis is an indispensable tool to evaluate the prospects on non-conventional water resources projects, taking into consideration potential benefits for different stakeholders. Often projects with negative cost-benefit analysis, when looking only for the direct users, can become interesting when considering the potential benefits for the community and territory, justifying public incentives to encourage the adoption of non-conventional water resources. We should consider shifting our traditional ways when looking at water supply, relying not exclusively on fresh water, but also non-conventional water resources that can lead the way to resilient cities ready to face future challenges.